You probably don't know. Okay? So it's not going to come out easily. Stared at it long enough, it probably would. We don't need to stare at it that long. Okay. Well, 2 to the 3/4 could be written in 2 ways. We could write it as 2 to the 3rd to the 1/4. If you multiply 3 by 1/4, you get 3/4, right? Just by, again, the second rule. Or we could write it as 2 to the 1/4 to the 3rd. Same thing. Or we could write it as 4th root of 2 to the 3rd. That's connected to this, right? The 1/4 power something we could write as the 4th root. So this one and this one are just the same thing, but this one with radical notation, right? Okay. Or we could write it as the cube root of 2 raised to the 4th. And that's just another way of writing this. Make sense? Okay, so excuse me, 2 to the 1/2 means what? Well, it's a number you multiply by itself. We get 2, right? So 2 to the 1/2 is the square root of 2. Because the square root of a number is a number you multiply by itself to get that number, right? And I write this to indicate that if it's a 3rd, 4th, 5th root, we've got to put the 3, the 4, the 5 in here. This is not read as the 4th square root of 2, right? It's the 4th root. Okay, a lot of people read that as 4th square root. We don't have to put a 2 in here because if there's nothing in here, it's automatically the square root, right? Okay? So that's radical notation. Okay? Now, let's say we have an equation like x to the 1/3 equals 4. How can you solve that equation? What can you do to both sides of the equation that keeps it true? We can multiply both sides by the same number, divide, add, subtract. None of that's going to help. Okay? And I'm not going to drag this one out either. Because most people, in my experience, don't. I wouldn't be surprised if some of you, I wouldn't be surprised if all of you do, but I'm not going to assume it. Okay? Well, if I raise x to the 1/3 to the 3rd power, What's that going to give me? I'm sorry?
4.
No, not just x to the 1/3 cubed. Forget about the 4. How would you simplify x to the 1/3 cubed? What rule would you use? Okay, go back to the rules here. Only got 2 of them. And there are more rules than that, but those are the 2 that we're focusing on right now.
The second one.
I'm sorry?
The second one.
And, well, okay, what would the second one tell you to do? Well, second rule tells you that x to the 1/3 to the third is x to the 1/3 times 3, right? What's 1/3 times 3? So that's x to the 1, which means that's x, right? Now, what did I do to this side of the equation? Because this isn't the same as this. What's the difference? I raised it to the 3rd power, cubed it, okay? Well, I've got to do the same thing to this side. If I do, then I still get a true statement. If this is true, then this is true, okay? And 4 cubed, 4 times 4 times 4, 64. Okay? Make sense? Okay. So you really have to know these rules and internalize them, so you've got to practice them. Okay? So let's just do a couple more equations. Let's say you got t to the 2/3 equals 5. Now you want to get t, right? So you want to end up down here with the t equals whatever comes out. So how are you going to get from t to the 2/3 to t? Well, again, this is new, so don't expect you to see it instantly. But okay, let's ask what power could we raise t to the 2/3 to get t to the 1st power? Of course, you're not used to working with fractions. We did something last week. Probably the first time you've actually had to do a fraction since you were 10 years old. So it's rusty. We've got to fix that. But we're in the process of doing so. So let's see, what do you multiply t to the 2/3 by? What do you multiply? Okay. What would you multiply by 2/3 to get 1? I see some heavy-duty thinking going on back there. Again, a little unfamiliar, okay? You can ask just about any 5th grader after they've done their unit of fractions, they'd be able to answer it. But, you know, 30 years later, y'all are about 40, aren't you? Okay, no, 15 years later, 10 years later, whatever, okay? If you haven't used it, you're not going to remember. You're not going to have the instinct. You want to say, you look like you've got a brainstorm. Go ahead.
Is it 1/3?
No, but let's see why not. Thank you. I'm glad you answered. Let's see. T to the 2/3 raised to the 1/3 would be t to the 2/3 times 1/3. Well, what's 2/3 times 1/3? It's 2 to the 2/9. You multiply fractions, just multiply the numerators, multiply the denominators. Simplest operation could possibly be. And we have talked about why you can't do that with adding fractions. It wasn't handed down the stone tablet that you're going to have the same denominator. It's common sense that you have to have the same denominator, okay? But if you want to treat it as something that's handed down the stone tablet for now, okay, right? Yeah.
Would be, 3 halves.
Yeah. I figured once you'd seen this, it might jog your thinking, okay? So that doesn't work. But it stimulates the right answer. So, I mean, if you tried this and wrote it out, you'd say, oh, that didn't work. What could I do that would, right? So you always try something and then think about why it worked or didn't. Okay? So you got t to the 2/3. You're going to raise that to the 3/2. That gives you t to the 2/3 times 3/2, which is t to the 6/6. 2 times 3 or 3 times 2, right? Which is t to the 1, which is t. Okay? So there it is. Simplest thing you could have. If you got something raised to a fraction of power, you raise it to the reciprocal power. Okay? Remember about reciprocals? Again, teach you how to do fractions, put a calculator in your hand, never have to do them again, you forget. But it's not hard. Okay? Just gotta spend a little time on it. Okay? And the whole reciprocal thing's part of that. So that's 25 to the 3/2. Okay? So that gives you t equals 25 to the 3/2. Now let's think about 25 to the 3/2. What's that mean? How could you write 25 to the 3/2? You know, kind of scratch over here. 25 to the 3/2 could be written as, give me an example. What did I do over here?
Square root of 25 to the 3rd power.
Yeah, you cut right through the whole thing, okay? Now, if you don't cut through the whole thing, you can go back to what I did here, right? 25 to the 3/2 could be written as 25 to the 3rd to the 1/2, or 25 to the 1/2 to the 3rd, or the square root of 25 to the 3rd, or as the square root of 25 raised to the 3rd, right? Now, which of these has something you can compute easily? Well, you can compute 25 to the 3rd. You know, 25 squared, 625. Multiply that by 25, you get 6,000. I don't know how to do that. Okay, right? Okay. Or you could do this, if you recognize 25 to the 1/2 is the square root of 25, then it's got to be 5, right? Okay? And you might not have to write the radical, but if you write, if you don't notice that that's the square root and that's 5, when you write it this way, oh, there it is, right? So anytime you don't know what to do with a radical expression, I would write it out all 4 ways, or the fraction expression. you've got it in any of these forms, you should be able to write it in any of the others, and then use the one that works best. And pretty soon you develop an instinct for which one to use, okay? And you don't have to write them all out, but at first it doesn't hurt to write them all out, so you're aware of all the different ways you can do it. Okay? Okay, so that's 25 to the 3 halves. So we could say that, okay, well, t equals then the square root of 25 to the 3rd, which is 5 to the 3rd, and 5 to the 3rd is easy to calculate. I mean, 5 squared is 25. Now if you got 5 quarters, how much money you got? You got $1.25. Okay? Make sense? Okay, well that's pretty good. I'm going to give you some problems to chew on for a few minutes.